Hey guys, welcome back to the channel. Today we are going to delve deeper into the world of outer space and look at the greatest telescope ever invented. Here I am going to tell you some facts about the James Webb Telescope. We wonder, it's our nature. How did we get here? Are we alone in the universe? How does the universe work? The James Webb is basically an ambitious scientific endeavor to answer all these questions. The James Webb Telescope basically builds on the legacy of previous space-based telescopes to push the boundaries of human knowledge even further to the formation of the first galaxies and horizons of other worlds. The James Webb Telescope, or abbreviated JWST, is a space telescope specifically designed to conduct what is known as infrared astronomy. Its high resolution and high sensitivity instruments allow it to view objects that are too faint or far for the Hubble telescope to view. This enables investigations across many fields of astronomy and cosmology, such as observation of the first stars, formation of the first galaxies, and detailed atmospheric characterization of potentially habitable exoplanets. As an infrared telescope, Webb will explore science questions to help us understand the origins of the universe and our place within the universe. The JWST is made up of 18 gold-plated segments which make up what is known as the iconic mirror. The mirror on the JWST is 6 times bigger in area than that of the Hubble telescope and about 100 times more powerful. The 18 primary mirror segments are covered with a golf ball size mass of gold, which optimizes them for reflecting infrared light. The coating is so thin that a human hair is 1,000 times thicker. Basically acting like a powerful time machine, Webb seeks to detect light from the first luminous objects in the early universe and basically watch how galaxies have evolved through cosmic time. Webb's infrared capabilities will allow it to gaze into the age when the very first stars and galaxies were formed over 13.5 billion years ago. Webb is so sensitive that it could detect the heat signature from a bumblebee at a distance from the moon to the Earth and can see the details the size of a US penny from 40 kilometers away. More than 1,200 scientists, engineers, and technicians from over 14 countries have taken part in designing and building the Webb. The entire project is a joint mission between NASA, the European Space Agency, and the Canadian Space Agency. JWST was launched by an Ariane 5 rocket from French Guiana on the 25th of December 2021. Webb's primary mirror segment consists of 18 hexagonal mirror segments, which in total form a diameter of about 6.5 meters, which is 7 times larger than that of the Hubble telescope. The reason for having 18 hexagonal mirrors rather than just one mirror was that it would be too big to successfully launch into outer space, and therefore the mirrors had to be made in a way that they were folded and then unfolded automatically once the telescope was in outer space. The Webb telescope uses 132 small actuation motors to position and adjust the optics. The actuators can position the mirror with a 10 nanometer accuracy. To put it into perspective, think of it this way. 10 nanometers is equivalent to 0.00001 millimeters. Just imagine how expertly the telescope was made to accurately open its mirrors remotely, where even a 10 nanometer allowance could spell disaster for the entire mission. The telescope primarily detects light in the infrared in order to observe sources such as the first galaxies and protostars that radiate at those wavelengths. Since infrared satellites have to be protected from thermal radiation, a sun shield of about 150 square meters in area protects the telescope. One of the most interesting things about the telescope is that there is no rocket that would be wide enough to hold the James Webb Telescope at its deployed state, and therefore both the sun shield and the primary mirror were launched folded and then unfolded automatically in space. Another interesting fact about the James Webb Telescope that it is not intended to be serviced in outer space like the Hubble telescope. Similarly, a remote servicing mission is not possible as this is beyond the available technology at the time the James Webb was designed. The James Webb Telescope has successfully arrived at its final destination about 1 million miles away from Earth. The telescope will orbit around what is known as the Lagrange L2 point, which is on the far side of the Earth from the Sun. The initial design of the telescope, which was then named the Next Generation Space Telescope, began in 1996. Two concept studies were commissioned with a potential launch in 2007 at a budget of $1 billion. The program was plagued with enormous cost overruns and delays. A major redesign was done in 2005, with construction completed in 2016. Followed by years of exhaustive testing, the total cost of the project stood at, wait for it, drum rolling, $10 billion. However, one should not look at the $10 billion as being a one-time payment for a mission to outer space. The project itself started the planning phase in the early 1990s. This implies that it has taken over 31 years of planning, designing, redesigning and testing for the mission to actually be a success. Although the JWST has bigger mirrors and a larger sun shield, it has been constructed by special material which has drastically reduced the overall weight of the telescope and slashed it by almost half in comparison to the Hubble telescope. The project has not been all roses since the initiation and has faced several budget and technology challenges. In April 2010, the telescope passed the Mission Critical Design Review, which was known as the MCDR, and final construction was completed by 2016. In March 2018, disaster struck, and the project had to be delayed for an additional 2 years after the telescope's sun shield was ripped during a practice deployment. Now that was one expensive mistake. The independent review board identified 344 single-point failures that the Webb telescope had during launch and deployment, and basically they had to be addressed before the project was given a green light. After the final test done at the Northrop Grumman factory in California, the green light was finally given for the project. A ship carrying the telescope left California on the 26th of September 2021, passed through the Panama Channel and arrived in French Guiana on the 12th of October 2021. The successful launch of the JWST took place on the 25th of December 2021. A special mention does go out to Gregory Robinson, who was appointed the director of the Webb program in 2018. Robinson was able to raise the project effectiveness from 50% to 95% and was hailed the most effective leader in the history of NASA by his supervisor, Thomas Zurbuchen. The billion-dollar question then is, why spend that amount of money on a mission to outer space? The JWST aims to answer 4 questions. 1. To search for light from the first stars and galaxies that were formed in the universe after the Big Bang. 2. To study galaxy formation and evolution. 3. To basically understand star formation and planet formation. And finally, number 4, to study planetary systems and the origins of life. These questions can only be answered by the Webb telescope because these goals can only be accomplished by what is known as infrared astronomy. If you're interested in Webb's journey in outer space, you can follow this live on the NASA website, where they provide updates such as the location for the JWST and live or recent pictures that have been taken by the telescope. Are we close to finding out the origins of life and the Big Bang? Will we find proof of life in other planets? We might not need to wait very long for these answers. Thanks, and don't forget to leave a like, share and subscribe to the channel, and we'll catch you guys next time for more facts about anything and everything.